Hi everybody, welcome to this short video tutorial series. We're going to be looking at how to build a linked list of node objects in Java. We're not going to be using Java's linked list class, however. We're just going to design our own solution. So we're going to look at how to build a list by inserting new nodes at the end of the list. And later in the series, we'll look at how to insert a new node at the beginning of the list. Now, a linked list of nodes has node objects, and each node object has data and a reference to the next node in the list. This reference's data type is going to be node, because it references a node. It doesn't reference a string. It's not being assigned an integer. It references a node. We can also see that the last node in the linked list, the next pointer or the next reference references null. This is how we know that we've reached the end of the list. Finally, to process a linked list, we will need an external pointer or reference. And this reference is going to point to the first node in the list. We can also imagine that because root is referencing a node object, its data type will be node. Okay. Now when we construct a new node and we try to assign this node to the list, we try to insert it at the end of the list, one of the first things we need to ask ourselves is the list empty at the moment? If the list is empty, our external reference is going to reference null, or something equivalent to that. That's how we know the list is empty. So in Java, what we can ask ourselves is, if root is null, we're simply going to assign our new node reference to root. And when we do that, this is what happens. Root becomes, or references, the same node that the new node reference is referencing. Okay, so there's something to think about before we jump into our IDE and start programming. Alright, let's get started. The first thing I'm going to do is declare and initialize my root pointer. The list is empty, so I'm going to assign it a value of null. The next thing I'm going to do is construct a new node. I'm going to call it n1. Remember, n1 is just a reference variable to a node object. And let's give it some data. There's one thing I do need to tell you before we continue. I have designed the node class, and I'm keeping it really simple, guys. I'm not going to be using data hiding. I'm not going to have the distraction of accessor and mutator methods. Other classes will be able to access node attributes directly. These are public. Okay. And when we construct a node, we give it some data, which is assigned to a property, and we assign the next reference, which is of type node, to null. So when we construct a node, this is what's happening. We give it some data, and we assign the next reference to be null. There we have a new node. Okay. So that's what the node class is going to do for us. So let's construct a new node, and then I'm going to be modularizing my solution in this tutorial series just to help me manage my idea. So what I'm going to do now is call a function that I'm going to design. I'm going to call it insert at end. Now this function needs to know where to start, so the root reference will tell us where to start, and it also needs to know which node to insert into the list. So we're going to send it this n1 reference. Okay. Now let's look at the design of this function. I've already started down here. Let's just get rid of some of this white space. So insert at end processes a node reference, which I'm going to call root, and another node reference, which I'm going to call new node. Okay. And as we've just discussed, if root is null, it means the list is empty. So all we have to do is assign the new node reference to root. Okay. So that's really the first thing we want to do. Check if list is empty. Else, if it's not empty, it means there are already some nodes in the list. So we need to go searching for null and find the last node in the list. Right? We need to go and find the last node in the list because the last node's next pointer is going to point to our new node. So we need to go and find this node. And this is the node that points to null. Okay. Now we could use our root reference to visit each node in the list as we go hunting for null. But I would suggest to you, don't move root. Root is very important. It allows us to understand where the start of our linked list is. Don't mess with root, guys. What we really want to do is construct a new reference variable, which also points to the node that root is pointing at, and we're going to use this to go searching for null. So it's going to visit this node. Is the next referencing null? No. Keep moving. Is the next referencing null? No. Keep moving. Is the next referencing null? Yes. We found it. We found the last node in the list. So that's what we need to figure out how to do in our Java code. So, don't move root. I'm going to design a new node reference called search, and I'm going to assign it the value or the node that root is referencing. Okay. Now check out this funky little algorithm, guys. While search.next doesn't equal null, we're going to update search. We're going to allow search to visit each node. Ooh, now have a think about that little loop there. While search.next doesn't equal null, we're going to update search. Search will be assigned search.next. Now let's have a very quick look at how that works. Let's say that we've said, okay, search equals root, while search.next, this is the next, doesn't equal null. That's true. That's true. So search equals search.next. Can you see how that works? Search references the same node as search.next. While search.next doesn't equal null, that's true, search equals search.next. While search.next doesn't equal null, that's true, search equals search.next. While search.next doesn't equal null, that's false. The while loop is finished, and the search reference is referencing the last node in the list. So we can now process this node. All we need to do is assign search.next's value to be whatever our new node reference is. And we've just inserted a new node to the end of a linked list. Okay, so let's go back. When the while loop is finished, search will be referencing the last node in the list. So search.next will be assigned the new, whatever node new node is referencing. Now I'm just going to leave this video here for now. And I want you to take some time to build this and just see if you can get the program to run without any errors. I don't think there's any output at the moment. You might find ways to put in some output so you can see what's going on. But we'll look at that in the next video. Okay,